Okay, last video of this segment or this topic set. This is our third law of motion now. And we're actually now looking at interactions between objects. Again, I'm going to kind of pull up what our 9th grade definition is. You might remember what the 9th grade definition was, or at least the way that we talked about it. We said that for every action there's an equal and opposite reaction. Okay, what this really meant, and what Newton was really trying to get at, is that if two objects interact with each other, okay, they provide forces against each other that are equal and opposite. Okay, so I have a picture here with a bat and a ball. So the bat is applying a force to the ball. Well, the ball has to apply a force that's equal and opposite, okay, I should say in the opposite direction as what the ball is applying to the bat. So the bat applies a force to the ball and the ball applies a force to the bat, and they're equal and they're opposite. Okay? And that's how we kind of look at all of these situations. So there's always going to be interaction between two objects, and that way when we look at that object, that one particular object, we then can equate it into the forces that are applied to that object itself. Okay? When we start talking about these interactions or these various types of force, we need to describe what are the differences between forces. So I'm going to look at this in terms of contact forces and non-contact forces. So let's talk a little bit about what is a contact force or contact interaction. Okay? And so you can see I've got a list there. It's normal, frictional, tensional, and applied. Okay? And I'm going to kind of say the applied's the easy one. Oops, I got to get my pen going here. The applied's the easy one because the applied force is the one that I am applying. So I push on a box, the box pushes back on me. I walk up to a table, I push on a table, the table pushes back on me. Okay, that's the applied force. Okay, so I push on an object, that means that it's an applied force on the table. But keep in mind that the table, the interaction back between us, because we're in contact with each other, is that the table pushes back against me. When then we start talking about tensional forces are things like through ropes, through chains, through cables. Okay, it's like a stretch through something that's being connected. So if I hang a mass off of a string, okay, the mass puts a tensile force through that string. Okay, and so that string then pulls back on the object, and we'll start seeing how those forces get transferred into a free body diagram. Frictional forces happen anytime we have contact between two surfaces and we try to slide between those surfaces. Okay, so there's a frictional force that acts opposite the direction of where we're going, and there'll be an entire video dedicated to talking about friction. Okay, so we'll talk about frictional forces. The last one is the normal force, and that's the one that I think sometimes is the most confusing to kind of understand when we start to look at our forces and force diagrams. So let's just say I have a table here. Okay, there's my table, and I put a box on this table. Okay, so the box is interacting between the tables. So in other words, the box applies a force on the table, and the table applies a force on the box. That's my pairs, okay? So again, forces always come in pairs. But then when we go to try to say, well, what is actually happening to the box itself? So we translate from Newton's third law of motion, where we're looking at reaction pairs, action-reaction pairs, to a free body diagram. Okay? Now, the box applies a force downward on the table. And the reason why is because the gravity is acting on the box. So we have a force that we call gravitational force. Okay? That's the weight of the object. The table applies a force upward to the box. So in other words, there's another force that's being acted on on the box, and that force upward we have a name for, and it's called a normal force. And a normal force is any force that acts perpendicular to two surfaces in contact. So I have surface 1, surface 2. The perpendicular one is perpendicular to that, so that's my normal force. Now the normal force can kind of it's really kind of one of these forces that we use only to draw in a free body diagram, and we label it usually F of n, okay? And it grows to put balance in there, okay? It's my one that actually makes it look like I have balance forces due to Newton's first law of motion. So the box is not moving, it's at rest. And the whole reason why it's at rest is because the forces have to be balanced. So the normal force is the balancing force that makes gravity balance out. So in my arrow situation, the upward arrow and the downward arrow are going to be equal to each other. And that's called the normal force. It's a contact force. It's the force that's perpendicular to the two surfaces that are in contact. Okay? Now I already wrote one of my non-contact forces up here, or my added distance interaction, and that's that gravitational one. So F of G is a gravitational force. It's again, when we say it's added distance, it's because the core of the Earth versus the object itself, there's a distance between us. And that distance happens even between the sun and the Earth, and it happens between the moon and the Earth, and really it's happening between any two objects that are at a distance from each other. The other two added distance forces are the electrical and the magnetic ones, and we tend not to talk a lot about those right now, but they work very similar to gravitational force. In fact, when we start to look at electrical forces between two point charges, it looks almost like the gravitational formula, gravitational universal law of gravitation, which is where we'll get into where that gravitational force comes from. One of the comments that I want to make here is we are kind of at the end of the Newton's three laws of motion, and this is one of the things that I want you to start thinking about. If you look down on the bottom of the YouTube video, in the description you're going to see that there's a little link there, and that link is something that I want you to do as a check-in. Okay, it's kind of, you got done watching the laws of motion videos, now I want you to go ahead and sign in. Let me know that you watch them. Okay, so it's a form that you're going to fill out. But I want you to think in terms of make a good question. What's a good question? So we just got done, I gave you a bunch of information, and I know that you probably took great notes on it. But there must be something that you have a question about when it comes to this stuff. Okay? And if you have that question, put it in the document. So you're going to see a box that's going to say, question after watching videos, okay? And so that's what I want you to do, is make sure that you kind of give me a question that we can actually work on as we're kind of going through it. And I want it to be a specific type of a question. Say, how does that, such and such work, okay? So think about a question, formulate a question, and that's kind of the end of what you need to do for this topic set with the videos for this. We'll see you tomorrow, and remember, happy physics.